Hey everyone, welcome to the 3.4 notes. Today we're going to talk about isosceles and equilateral triangles, and then we're also going to throw in Pythagorean theorem and its converse. Okay, so the first thing we're going to talk about is the isosceles triangle theorem, aka ITT. And this says that if two sides of a triangle are congruent, which an isosceles triangle has, then the angles opposite those congruent sides are congruent. So when you look at this picture, if these are my two congruent sides, the angles opposite them are congruent. So remember, the congruent sides, what are those called? Legs. And those two angles are called the base angles. So the base angles will be congruent. So the converse of the isosceles triangle theorem says if two angles of a triangle are congruent. So in this case, if angle A is congruent to angle C, then the sides opposite those two angles are also going to be congruent. So AB is going to be congruent to BC, or CB. Let's write it CB to stay consistent with my ordering. Okay, so as it says in red, I can prove both of these by drawing in an auxiliary line. So I'm going to do that for the second triangle here. I'm going to draw an auxiliary line through B. And now, if this is parallel to this, I get a bunch of angle relationships. But first, I'm going to draw an altitude from B down to AC. An altitude, if you recall from the last video, is a segment that starts at a vertex and then is perpendicular to the opposite side. So right here, what I've drawn is a vertex, an altitude. I'll label that point D. So in this particular problem, I was told that the two angles were congruent. So angle A and angle C are congruent. Because angle A is congruent to angle C, if I think of this right here, this is my transversal, these are my parallel lines, I know that this top angle here also is going to be congruent to this bottom one. So this angle and this angle are congruent. This angle was originally congruent to angle A, so by that same idea, if I think of this as my transversal, and then these are my parallel lines, this angle has to also be congruent to that bottom angle. All right, in these triangles, they share side BD. So if I was to label using one of my triangle congruence theorems, I have angle, angle, side. So by angle, angle, side, triangle ADB is congruent to triangle CDB. Because they are congruent to each other, that means all of their corresponding parts are congruent. So all the things I haven't marked congruent are now congruent. So AD corresponds to CD, those are congruent. These top angles here, they're congruent. And then the sides of the triangle, BC, is going to be congruent to AB. So if I have a triangle where two angles are congruent, then the opposite sides are also going to be congruent. If I was to do that up top here, let me erase my markings. If I was to draw the auxiliary line through B, draw the altitude from B to AC, I know this side's congruent to itself. So by hypotenuse leg, in this case, the two triangles will be congruent because it's a right triangle. When I drop an altitude, I have a right triangle. The sides are congruent to themselves. This is the leg. These are the hypotenuses, or hypoteni, maybe. And so therefore, the two triangles are congruent. So all of their corresponding parts would be congruent. So I could show A is congruent to C. The angles are congruent by CP, CT, C. Okay, so corollaries to the isosceles triangle theorem and its converse. If a triangle is equilateral, so if I have a triangle who has three congruent sides, then it's always going to be equiangular. And I could actually draw my double arrow because it goes both ways. And so here it shows the opposite way. If a triangle is equiangular, then it is equilateral. So anytime you have an equilateral triangle, automatically you know it's equiangular. So what would each angle measure? Well, if all three angles have to add up to 180, if they're all equal, they're all going to be 60 degrees. So let's take a look at the first example here. We are given that AB is congruent to BC. So I'm going to mark that in my picture by putting tick marks on those two sides. And as soon as I do that, I notice that this is a quadratic. I have y squareds, I have y's, I know it's a quadratic. So therefore, we are going to set those two sides equal to each other and figure out what else we need. There's a little typo here. This is supposed to say find the measure of angle A and x. So we'll go ahead and do that, and then we have to find AB. So let's find the measure of angle A first. Anytime you have an isosceles triangle, you only need one angle to be able to find the other two. So what I mean by that is if this is 80, and I know that these two angles are congruent, if the vertex angle took up 80 degrees, what's left for each of these to share? 50 degrees. The opposite would be, it would not be the same, I mean not the opposite, but it would be different if I was given that this is 80. If these were my congruent sides, then I know if this is 80, then this angle has to be 80. What do those two add up to? 80 plus 80 is 160. What's left for the vertex angle? 20 degrees. So anytime you have an isosceles triangle, you only need one angle and you could find the other two missing angles. So again, here, the vertex angle was 80. That means the base angles have 100 degrees to share between themselves. So then I know 6x plus 8 has to equal 50. And I'm going to solve this for x. Subtract 8 and divide by 6. So x is going to end up equaling 7. So let's go ahead and figure out here. We'll do x equals 7. And the measure of angle A was 50 degrees. Okay? To find segment AB, the length of segment AB, I have to set the two sides equal to each other because I need to find what y is. So I'm going to have y squared plus 6y minus 10 equals 4y plus 5. This is not a problem that I can use square roots on, so I have to get this to equal 0. I will subtract 4y and subtract 5 from both sides. I like to bring over everything to where my squared term is going to be positive. So I have y squared plus 2y minus 15 equals 0. I'm going to factor this. What are two numbers that multiply to be negative 15 and at the same time have to add up to 2? They are positive 5 and negative 3. Be careful with your signs because if I flip these signs, it would be a minus 2y squared in the middle, and that's not what I have. Let's use zero product property. I'm going to get y plus 5 equals 0, so y is going to equal negative 5. Or if y minus 3 equals 0, y is going to equal positive 3. Since this is geometry and not algebra, we have to make sure that these answers make sense for our problem. Because y is now an expression for the side of a triangle, we have to make sure that it works. Meaning it's not going to give me a negative side length. I can't have a triangle if its side length is negative. So let's plug in negative 5 first. 4 times negative 5 plus 5. This is negative 20 plus 5. That's negative 15. So I cross out negative 5. Make sure you show that. You don't just cross out a negative value because you think it can't be negative. It can sometimes be negative. It depends when you plug it in what it's going to make your side length equal. If it equals a positive number, it's fine, even though the variable is negative. Okay, so now let's plug in 3. And when I plug in 3, I would get 4 times 3 plus 5. That's 12 plus 5 is 17. How can I double check that this is correct? I would plug it in on the other side because I know that these two sides are congruent. I'm going to make sure that I get 17 over here as well, because if I don't, I probably made a mistake somewhere. Okay, so 9 plus 18 is 27. 27 minus 10 is 17, so I can be confident that I found that correctly. Okay, example number 2. We know that triangle ADC is equilateral. So ADC, I'm going to mark the 3 sides as being congruent to each other. We are also given that angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. So we're going to have to find all the missing angles. Okay, so I know in my equilateral triangle, all of the angles are 60 degrees. They have to be, because an equilateral triangle is equilateral is equiangular, so all the angles are going to be 60. Now, I know that my two side triangles are going to be congruent by angle, angle, side, angle, angle, side, so they're congruent to each other. So therefore, I know that the vertex angles of these triangles right here, these have to be congruent to each other. So if I have a full circle, I know that x plus 60 is going to equal full circle, 360 degrees. 2x is going to equal 300. So x is going to equal 150 degrees. Okay, again, a full circle right here is 360 degrees. So I know then that x is 150 and 150. All right, we learned earlier, I mentioned, if you have an isosceles triangle and you have one of the angles, in this case we have 150, the other two angles share equally, these two congruent angles have to share equally what's left over. So what is left over is 15 degrees for all of these angles. They're all 15. And I wasn't asked to find those, but I did anyway, so that's okay. All right, so now we're going to switch focus to Pythagorean theorem, which we've done before, Pythagorean converse, and the Pythagorean inequality. Okay, so Pythagorean theorem, if you have a right triangle, you can find a missing side by taking leg squared plus leg squared equals hypotenuse squared. That's how I like to say it, because it's not always going to be A and B and C. Sometimes we're going to have different variables there. Okay, so the converse of the Pythagorean theorem says, if the square of the longest side of a triangle, if it equals the sum of the squares of the two shorter sides in the triangle, is a right triangle. So here, if you have a length that's greater than A, and then C is greater than B, and then if you square them, you take the longest side squared, so it's important to find the longest side, square that, and then compare to what it's going to be against A squared plus B squared. If they equal each other, then it's a right triangle. Now, the inequalities, this is a new theorem, because when you take the longest side, it's not always necessarily going to be equal to A squared plus B squared. So if you get that the longest side, C squared, is less than A squared plus B squared, less makes you think small, it's an acute triangle. Not all triangles are right. Now, if you take the longest side, C squared, and it's greater than A squared plus B squared, great, big, obtuse. It's going to be an obtuse triangle. So again, if you get that the longest side is equal, when you square it, is equal to the sum of the two shorter sides squared, C squared equals A squared plus B squared, it's a right triangle. If it's less than, it's acute. If it's greater, it's obtuse. So when you're going to be given three potential sides of a triangle and it's going to tell you classify by the sides, what you have to do, the most important thing, locate the biggest side first, because that's going to be C. You're going to say C squared and then see what is the relationship between A squared plus B squared. If it's equal, right triangle. If it's less than, acute. If it's more than it, it's an obtuse triangle. Okay, but one more theorem that we have to talk about, and it applies to all triangles, is the sum of any two sides of a triangle has to be greater than the third side. So, for example, if I had this long segment, and then I had this short little segment here and this short little segment here, these will not form, these three sides will not form a triangle because this is too short. The sum of those two blue segments that I circled is not greater than the third side, so therefore the triangle would not be able to be formed. No triangle would exist. Let's try some examples to see how this all works. Let's take a look at number 1 over here. It says to find the exact length of the missing side in each triangle. So I have right triangles. I could see that based on the right angle markings, and so therefore I'm going to do Pythagorean theorem. X, the leg, squared, plus the other leg, which is 9 squared, is going to equal the hypotenuse, 11 squared. Let's clean this up. 9 squared is 81. 11 squared is 121. Now I have to subtract 81 from both sides, so I have x squared equals positive 40. Square root both sides. To unsquare x, we square root both sides. Normally we would have plus or minus the square root of 40. However, because this is a side of a triangle, it can't be negative. So I only have x is equal to the square root of 40. Hopefully you realize we need to simplify this. What perfect square is inside of 40? A factor of 40? 4. 4 times 10 is 40. So x is going to equal the square root of 4 is 2 times the square root of 10. And that is our final answer. The second example here is a little bit more complicated because I see that one of the sides is a binomial. So I'm still going to do leg squared plus, and now when I do the other leg squared, I have to be careful. I have to make sure that I put this in parentheses and I square it, equals the hypotenuse 13 squared. We are going to have to clean this up. All right, so what we're going to do is FOIL it. We're going to write it twice. X plus 7 quantity squared is x plus 7 squared, x plus 7 times x plus 7. And this is going to equal 13 squared, which is 169. Okay, so I'm going to have x squared plus, when I FOIL this, first times first, x squared, outer plus 7x, inner plus 7x, and then last times last is plus 49, and this is going to equal 169. Let's combine like terms. I have an x squared plus an x squared. That is going to equal 2x squared. I don't add the exponents. Then I could combine 7x with 7x. That gives me plus 14x. And now I'm going to actually, in one step here, I'm going to subtract 169 from 49 just to save myself space here. And it's going to be minus 120 equals 0. Why did I equal it to 0? Because it's a quadratic that I can't use square roots on, so I had to get it equal to 0. Now I notice that there's a factor, a GCF of 2, so I'm going to take that out. It's going to be x squared plus 7x minus 60 equals 0. Let's check if this could be factored. Are there factors of negative 60 that at the same time will add up to 7? You could list them out: 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. There we go. Those are the ones. 5 is going to be negative because they have to add up to a positive 7. So this is going to end up being 2 times x minus 5 times x plus 12 equals 0. Use the zero product property, and we're going to get x equals 5 or negative 12. Plug these back in. Make sure they don't let the sides of the triangle be a negative number. If I plug in 5 on this leg, that's a vertical line, x would be 5, on the bottom would be 12, perfect. If I plug in negative 12, it is no good because it makes my sides, both of them, equal negative lengths. Triangles cannot have legs that are, any sides that are negative. Okay, now the last batch of problems here. I'll do the first 2 with you. You will do the third one on your own. First, we're going to determine if each set of numbers can be the sides of a triangle. And then if they can, we are going to classify them and as acute, obtuse, or right. All right, so the first thing I want to do is take the 2 shortest sides. It has to equal, or be greater than, the third side. 10 plus 24 is 34. That is greater than 26. Therefore, this triangle can be formed. So now I have to decide, well, what kind of triangle would it be? I have to find the biggest side. The biggest side here is 26. So I'm going to take 26, and I like to put this little blank with a question mark. I squared 26, and I'm going to see what relationship does it have to 10 squared plus 24 squared. 26 squared is equal to 676. If you have a graphing calculator, if you can't find the squared button, it's kind of diagonal to the top left of the 7 button. It's an x squared. So you just do 26 and then press that, and you'll get what 26 squared is. 10 squared is 100, plus 24 squared is 576. So what I end up with is 676, and when I add the two numbers on the right side, 676, because these equal each other, this is going to be a right triangle. Okay, next, we're going to take the two shortest sides, add them together, and make sure they're longer than the third side. Is 12 plus 14 greater than 30? 12 plus 14 is 26. That is not greater than 30. Therefore, there is no triangle. If there is no triangle, I'm not going to go and classify what type of triangle it is if it doesn't exist. Okay, for this last one, I would like you to try this on your own. If the triangle exists, remember you have to classify and see what type of triangle it is. Is it acute, is it right, or is it obtuse? Okay, so for number 7, you should have gotten that the triangle does in fact exist because the sum of the two shorter sides is greater than the third side. And then doing the converse, or the triangle inequality, you should have found that it is an obtuse triangle. Okay, find the longest side, square it, compare it to the sum of the two shortest sides squared, and see what you get. All right, that's it for these notes. You should be ready to work on the next section, 3.4 classwork, the next time you go to class. Thank you so much for watching. Have a great day. Bye.